Hey, Mr. Allred again for calculus class. I'm going over some odd problems I assigned. They're page 174, number 11. This is for 271. Number 11 is y equals 2 times tangent squared of x minus secant squared of x. Now, there's certainly no reason you have to rewrite it to see the exponents, but I will make sure I rewrite it just to let you see what's happening. So remember that tangent squared, even though we write it kind of funny, is something to a power. Okay, so I rewrote that with the power outside, and the same thing with the secant. So minus secant squared, and I'll write it so it looks more like a power rule. So we want to take a derivative. So y prime. So the first one here looks like 2 times tangent squared, looks like a power rule. With a chain rule. So the 2 that's out front stays there, and then the exponent of 2 comes out front, and that exponent reduces the 1, not that I need to write it, but the inside part, the tangent of x, is the u, so I'm going to put that in as I always do, and then the u prime goes on the outside. So as I write that in, it'll be 2 times tangent of x times derivative of tangent, which is secant squared. We'll clean that up in a moment. Okay. Then minus secant squared, I'm going to put the minus here, and once again this is another power rule situation where in this case what's being squared is the secant, so that's the u over here. Let me change colors just for those of you who care about that. Let me try and fix this. I know you may not have the color luxury at home, but this is a different u, so was used as a different color. But the derivative here, the power will come out front, so it'll be 2 times the u, which is secant, times the derivative of u. That'll be to the first power. But let's see here. Put the secant back in for u, and the derivative of secant is secant x tangent x. So there is a little bit of cleanup here I would do. That would be to write it as y prime equals the first one, which was 2 times tangent times secant squared. I'll write that as 4 tangent x times the secant squared of x. And the last part, which is minus 2 secant times secant tangent, I'll write it as secant squared tangent of x. And I wasn't expecting this, but I have like terms. So I have 4 of the tangent secant squared, and I'm taking away 2 of the tangent secant squared. So in the end I'll have 2 tangent of x times the secant squared of x. Pretty nice endpoint there. If you see different versions, let me know. So where am I going? Going to the right. Alright, so my next problem is 13, which is the function s times cosine to the 4th of 1 minus 2t. So let me rewrite it first of all. It'll be s equals, I'm going to use some different colors here, the cosine of 1 minus 2t, and that will all be raised to the 4th. Okay, so I'm just rewriting it so that what I see, first of all, when I go to take a derivative, is a chain rule, but it's the power rule with the chain rule. So let's see here. Let's go ahead and say that the original here, u, is cosine of 1 minus 2t. So my derivative will look like s prime. So I've got the 4th power. I'm using the power rule. The 4 will come out front, and it will go down to a power of 3. And what goes inside will be that u times the derivative of u. So the u that I had was cosine of 1 minus 2t. So what I want to do is I want to take the derivative of that. Well, if my u is, I'm going to kind of have some funny spacing here, but if my u is cosine of 1 minus 2t, to take the derivative of that, I'm going to use the cosine derivative, but with a chain rule. So in this case, the u is 1 minus 2t. So the derivative of this thing will be, derivative of cosine is negative sine with this u in it, and then times the derivative of u. So the u that I was working with now is 1 minus 2t, and the derivative of that is negative 2. So this is the u prime that I want for this blank that I left up here in the s prime. So let's clean that up a little bit. Negative 1 times negative 2 will be a positive 2, and that would be sine of 1 minus 2t. So I had to come down here and do an extra chain rule. So I had a chain rule inside a chain rule. But let's see here. If I want to clean that up a little bit, I don't have a lot of room, or I don't perceive myself as, but it'll be s prime equals 8. And then I can do, for the 2 times the 4, it'll be cosine cubed of 1 minus 2t. And that'll be times the sine of 1 minus 2t. Okay. And if they do something different in the back of the book, just let me know, and we'll take a look at it. All right. So what do we got next? 15 should be, okay. So 15 is the function s, and that is equal to the quantity of secant t plus tangent t all to the 5th. So I don't need to rewrite that, but when I go to take the derivative of s, what I have to realize is, yes, I'm using a power rule because it's to the 5th, but I'm also using a chain rule with a u of secant t plus tangent of t. So at first, as I carry out the power rule, I've got something raised to the 5th, so the 5 will come out front. The exponent will be reduced down to the 4th. And I'm going to put my original u back inside, and it'll be times the derivative of u, whatever that is. So putting my original u back in, secant t plus tangent t. And then the derivative of that, derivative of secant is secant t tangent t, and derivative of tangent will be plus secant squared of t. I don't know what I would need to clean up there. There's no like terms, and there's no real benefit to multiplying anything out. That's the way I will leave it. If something else happens, that's fine. If you're questioning the back of the book with something, just let me know and we'll take a look at it.